Hello everyone. We are now going to use the same diffusion equation that we have here to be solved into a different type of domain. So here we have two domains, 1 and 2, which are connected through the interface. We still use the same diffusion equation and show how to set up this kind of problem. So we start securely solved, and then we get this type of window. Let's draw the rectangular geometry in the bottom. Then we want to put another one on top. We introduce 2 points on the top side, and then we put 3 lines there. We connect them, connect the nodes. So we combine the points to make sure that they are well combined. Now we create the contour. So then we have a second domain. So this is a second domain here. So this is what we get here. So we have two domains connected. Each of the domains contains two equations, which is a default. So now we just go in and then set up one equation, one diffusion equation in each side. So we delete this one. We update this one here. Let's use this one. Okay. Ct is equal to 0. It's basically the same as putting c equal to 0, but let's do it for completeness. Remove that, get it to equal to 0. Then we have two parameters. We clear that, equal to 1. Okay. This one we clear, k multiplied by the power. We put p on top as a power. So we have two parameters. We define it, p equal to 1, then k equal to 0 for domain 1. So the two SR in two different domains could be different. So this is where we set up the parameters. So these are also the expressions for the parameters. The same, these parameters could be any type of mathematically valid expressions. So for the second domain, we do the same thing. We remove the second equation. We have this equation that we update. We update it to that. We remove that. We remove that, equal to 0. Again, we have a DEX on this domain, which is different from the other one. We also set up another one for this domain. We set a SR. So here we call it A multiplied by P. We can still call it K because it's not the same K. So this is a different expression in another domain. So they are not the same with the other one. So if you look at here, we see that the domain 1 contains two elements in the array. So they don't conform. So they should have the same number of elements. So when we come here, we change it to 1. So they have the same number of elements. So this domain 2 is this. In domain 1, P and K are defined. In domain 2, P and K are not defined. P, K, this one we put again to 1. K we put to 0. We can put, we don't need to put the same values for the two domains, but for the sake of the demo, we put them to be the same. So this is it. Now we need to define the boundary conditions. So these two domains are connected to the interface. What CKFreeSoft does is it applies an interface condition automatically. but we can still click there and see that we have a whole set of interface conditions that CKFluidSoft would select. In this case where there is no flowing fluid, so this continuity equation is the valid expression to use. So the other ones could also be used in some other cases. So this is what we have. So the interface condition is automatically set. Then we set up the values on each of the sides. So here we're using values of 1. Let's use 1 here, 1 and 0 there. So that so here we set opaque again, and then select that, and then we put the value of 1. We can change it from there, close. So, and then here, so all the sides, they have numbers on them, so we can just change them from within the box if we know the numbers of each of them. So let's pull it this way, and then we can view that, put it there, and then if the screen was big enough, we can see everything directly. So we have a number 1 and number 3. We set it to 0. So we have opaque condition that we set to 0 using opaque 0 already. Then on the top 0 and 1, so we use that. Here we put 0 opaque. Oh, this is the adiabatic conditions. All of them are zeros. There is nothing to set. We set the opaque, take that one, and then we take the other side is 0, this side is 1, opaque condition, this one is this side is 1. Let's check again. So we have that. The other ones are adiabatic. Here it's 0.5, so this one is 0.5. 0.5, close. So the next one is, the rest are all adiabatic boundary conditions, and then the interface conditions. So we have that. After we have set that, we can then set the initial conditions or initial guesses for each of the domains. So let's set it to 0.5, which is between 0 and 1. This one also set it to 0.5. So after that's done, we can then mesh it. So we have our mesh. Now we can run this problem to see what we get as a result. Compile it. So the compilation step will tell us that it was okay. Then we run it. Then we get our result. So these are the numerical results are in the background, and then we can then view the graphical result. So these are the graphical results for this solution. So this is what we get with this kind of setup, this kind of geometry. Again, we can customize this. If we click there, we customize that. Two domains. So this is the result. If we move our mouse around, we can view everything, every number that is within the solution. We can also draw the results along the lines if we need to do so. So if we select a line, we can view the result as well. We can customize the curve, and then we can see the numerical result in the background. So these are the numerical results for each of the domains. So we can copy those results, plot it into Excel sheet, or just look at them and see how they present themselves. So these are the results. This is the amount of time it took to run the solution. So this is it for this example. Thanks a lot. Thank you for your interest in using CK4Soft. So move out to another demo that we shall display in another section. Thanks a lot.